So one of the more difficult types of questions are these problems where you're asked to distinguish mixtures from pure substances through physical properties. And in these problems, what happens is you are given a written description of two samples, sample A and sample B, and you have to decide if it's possible to classify the substance or the mixture as either a pure substance, which means either an element or a compound, or a mixture, which means multiple pure substances physically intermingled. Now, sometimes it's not possible to distinguish whether you have a pure substance or a mixture, and you need to indicate that. So the key thing here is to recognize that mixtures are multiple pure substances that retain their individual properties. So what this means, that is, for each component of the mixture, you'll have an individual set of properties. So mixtures have greater than one value for each property. So typical properties we might be looking at in these problems would be the density. So there will be more than one density present. There'll be more than one melting point. There'll be more than one boiling point. There'll be more than one solubility. So a good example of there being more than one solubility is if you have a mixture of, say, sand and sugar. If you add water to that, the sugar will dissolve, but the sand will remain undissolved. Another example that we'll often see is that there'll be greater than one reactivity or interactivity. So in a mixture of, say, gasoline and water, only the gasoline would be flammable, right? Now, when we look at how things interact with other things, a good example of this is if we dissolve a substance into a solvent and we drip it onto paper. That drop of liquid will spread out, but if there's a mixture, the different components that are present in that drop of liquid might move through the paper at different rates because they have different ways of interacting with the paper. So what you end up with is like a series of circles, and which indicate the different substances moving through the paper at different rates. It's kind of like, and I've tried to illustrate this here, if you have like bees moving through a field of flowers, they're going to move quite slowly because bees like to stop and collect pollen. So, if you have a wasp flying through a field of flowers, well, they're going to go through quite quickly because they don't care about collecting the pollen. So the key thing that we're looking for is a mixture will be characterized by having multiple values for a given property. Now, a pure substance, on the other hand, is just has one compound or one element present, right? There are only two types of pure substances. It's either a compound or an element. And what this means is that there is one density, one boiling point, one melting point. There's only one value for any particular physical property because there's only one substance present. So a good example of this is melting point and boiling point. If I have a sample of ice melts at 0 degrees Celsius. So whenever an ice cube is melting, its temperature is constant at 0 degrees Celsius. If I have a sample of pure water, it boils at 100 degrees Celsius. That's the boiling point of water. There's only one boiling point of water. It doesn't matter how hard we heat it, you're never going to heat liquid water above 100 degrees Celsius because that's the temperature at which it boils. So let's have a look at some of these examples here. So it says sample A is 100 grams of a coarse powder with a faint, unpleasant smell. 15 milligrams of the powder are put into a very thin tube and heated. The powder begins to melt at 66.2 degrees Celsius. The temperature continues to rise until the powder slowly melts and the last of the powder becomes liquid at 76 degrees Celsius. So instantly, it's a mixture because there isn't just one melting point. There's what we call a melting point range, and that's indicative of there being multiple components there. Some that melt at 66.2 degrees, some that melt above that temperature all the way up to 76 degrees Celsius. If this was a pure sample, it would start melting at 66.2 degrees Celsius and remain at that temperature until the entire sample was liquid. So that's got to be a mixture. All right, let's have a look at sample B. Sample B is 100 mils of a clear liquid. The density of the liquid is measured and turns out to be 0.77 grams per mil. The liquid is then cooled in the refrigerator. At 10 degrees Celsius, 2 separate layers form in the liquid. When it's warmed back up, the 2 layers disappear. So what it means is that below 10 degrees Celsius, you end up with 2 layers of liquid. This one sinks to the bottom because it is more dense. This one floats on top because it is less dense, kind of like what happens with oil on water. So you have 2 substances present with 2 different densities. Now, what's going on here is you don't see this until you are below 10 degrees Celsius, because at that point, the 2 liquids become insoluble in one another, and you can see this difference, but it is clearly a mixture. Now, you might be aware of that the general rule of thumb is that as you raise the temperature of a liquid, the solubility of substances in it increases. That's why when we're doing cooking and we're trying to get, like, sugar or salt or something to dissolve in water, we'll warm it up and it'll dissolve more readily. Okay, I hope that helps you understand these types of problems concerned with distinguishing mixtures from pure substances through physical properties.